At the National Ice Core Lab in Lakewood, Colorado, a giant freezer stores over 45,000 feet of ice, drilled from 34 sites around the cryosphere. Dating back hundreds of thousands of years, these ice cores are time capsules that allow scientists like Jim White to peer deep into the history of ice.
This piece of ice is interesting because it has a couple of things you can see right away. One is there are bubbles throughout here. These bubbles are little packets of air. It's these bubbles we can take out and measure CO2 and methane and nitrous oxide. It's the only medium that really collects the atmosphere itself. The other thing you can see in here quite clearly is you can see the layers. And the thickness is going to tell you how much snow fell that year. So you get a couple of pieces of climate information and a dating scale just out of visually looking at this ice core.
Most importantly, scientists have identified a direct historical link between increases in greenhouse gases like carbon dioxide and steep rises in global temperatures. At every peak, big rises in sea level followed as Greenland's ice sheet shrank. The ice core records also reveal a particularly telling moment in Greenland's history. Roughly 125,000 years ago, temperatures rose by about 7 degrees Fahrenheit. The entire southern portion of the ice sheet melted, and global sea levels rose by over 10 feet. It was caused by a change in the Earth's orbit around the sun, which increased temperatures and released carbon dioxide from the oceans. The more recent ice core record shows the potential for a similar meltdown. Right now, greenhouse gas levels in the atmosphere are even higher than they were 125,000 years ago, higher than they've ever been in the last 500,000 years. Temperatures are already following suit. The only explanation is the burning of fossil fuels.
What we see in this ice core is very solid evidence that what's happening today in the atmosphere is different. It's not a normal part of the climate cycle. It's something caused by human beings.
Rising temperatures are once again pushing Greenland towards a major meltdown. But what the ice cores can't tell us is how long it will take. The last time Greenland lost a significant portion of its ice, White suspects it happened over thousands of years. But this time, it could happen much faster. So far, global warming is biting hardest at the fringes of Greenland's ice sheet. Ringing the island are hundreds of outlet glaciers that act like pipes, draining the interior ice sheet out to sea through narrow fjords. In the late 1990s, many of these spigots began gushing more ice. One of the largest, Jakobshavn, is now pumping out over 40 billion tons of icebergs each year, more than any other glacier in the northern hemisphere. During the summer melt season, Jakobshavn is now moving at a clip of 130 feet per day, almost twice as fast as a decade ago. The faster it goes, the more pressure builds up behind the glacier's 400-foot-high calving face. This triggers more frequent and explosive calving events. In the spring of 2008, Balog's team was staking out Jakobshavn and got lucky, capturing the largest calving event ever filmed. In the space of about an hour, a section of ice as wide as Manhattan sheared off the glacier.
We've underestimated the sensitivity of these systems. We are approaching the threshold of viability for the Greenland ice sheet, and that's when the melting occurs high enough on the ice sheet that no matter how much snow accumulates, there's net loss every year.
Greenland is already losing 150 billion tons more ice every year than it gains in snowfall. As temperatures go up in the coming decades, even more ice will be lost. The hard part is figuring out how much and how fast. The summer melt season on the Greenland ice sheet has grown hotter and is now 2 weeks longer than it was only a decade ago. Rivers of meltwater cut deep into the ice, creating a serpentine canyon that winds for miles. As the summers heat up, features like this ice canyon are becoming more pronounced. But for all its beauty, it raises perplexing questions about the effect this water is having underneath the skin of the ice sheet. The strangest phenomenon is the mystery of the meltwater lakes. As the ice sheet cooks down, the meltwater collects in depressions in the ice, forming thousands of lakes, some over several miles wide and nearly 50 feet deep. From satellite images, scientists noticed that in midsummer, many of these lakes vanished overnight, leaving bright circles where the water once stood. Until recently, it was assumed that the water was absorbed and refrozen into the ice sheet. Instead of being absorbed and refrozen into the surface ice, they discovered that the water dropped all the way to the bedrock. There, it lifts and lubricates the ice sheet and accelerates its slide.
Ah! Oh my God! Not being roped up here is one of the scariest, dumbest things I've done in my life. Where I'm laying right now was underwater just 6 hours ago. You know, there was a lake here, and the water depth of the lake was roughly 20 feet right here. And all of that that was overhead 6 hours ago is drained out and poured down this hole. And I can see maybe 250, 300 feet down there. I'm not feeling real comfortable out here.
Now they know. These billions of gallons of water are finding a route under the ice and out to sea, lubricating the outlet glaciers and making them speed up. The ice may have more surprises to come, but based on the latest research, the best guess for future sea level rise comes down to a simple calculation. In the next 100 years, the oceans will expand on their own as they warm, accounting for about a foot of sea level rise. Another foot will likely come from the loss of the world's mountain glaciers as they melt away. The ice sheets of Greenland and Antarctica won't disappear, but their combined melt is expected to add about another foot. The total equals an estimated sea level rise approaching 3 feet or 1 meter by about 2100. It may not sound like much, but over 100 million people live within 3 feet of sea level. Cities around the world will spend trillions building up coastal defenses. Low-lying regions such as Florida, Vietnam, and Bangladesh will be devastated. Many island nations will cease to exist. The consequences will test our ability to adapt like never before.